Hey Math 1, I've got a new video for you. It's over lesson 2.2. We're solving equations again just like the first one, and we're still documenting each step along the way as a proof. The only thing that's different is these 5 properties for proof that we used in lesson 1 are going to need some additions to them. Because right now we have to deal with grouping symbols and simplifying variable expressions like we did in the last 2 sections of chapter 1. We have to incorporate those properties of proof now. So we have to bring the distributive property back. This was LPO. We'll just call it Yeah. Remember, the distributive property was when we multiplied to get rid of parentheses. We have the commutative property. That's if we want to get the like terms side by side, and I'll show you how to do that on this first one. And then the last one is the substitution property. And in the context of solving equations, that one's pretty much always going to follow the commutative property when it comes up. So let's just dig into our first example. We're going to be going back to this little chart here pretty much constantly, so I'm going to try to keep it in view. Okay. So I want you guys to be able to solve equations involving decimals and fractions as coefficients, and be able to solve equations with parentheses. All right, so we're given 2a plus 3. I'll write this a little bit bigger so we can see it better. All right. Your first move is to get rid of these parentheses so that we can actually combine the a's together and combine the constants together. So this is the distributive property. So I'm going to take 2 times a, which gives me 2a, 2 times positive 3, which gives me positive 6. Negative 4 times 4, which is minus 16. And then a negative 4 times a positive 3a, that's going to be negative 12a. And all I want you guys to do is, after you do that step, you just point over here and say, that was the distributive property. Now the next move is we have to simplify this expression on the left so it looks kind of like the problems we did on the first one. If you got a good sense for how to solve equations where it was like an a term plus or minus a constant equals a number, then that's what we want to create on the left-hand side. So I'm going to do a little highlighting here. I'm going to say I want to bring the positive 2a and the negative 12a together. Okay? And then I want to, well, these are already side by side, but this is what we would do. We'd say we want these two to come together as well. So 2a minus 12a would be the next line. Okay? Plus 6 minus 16 equals 5. That would be the commutative property, getting your like terms side by side. See? We've got our a's together. We've got our constants together. Now simplify. 2 minus 12 is negative 10, and then you would keep the a on the end of that. Positive 6 minus 16 is negative 10, and that equals 5. This would be a substitution property deal because all we did was simplify after the like terms were put side by side. Hopefully that makes sense. This came from the yellow. This came from the magenta. All right, now it looks exactly like the problems you guys saw on 2.1. So how do we solve that? Well, we want to get our constants on the same side as one another. So you're going to add 10 to both sides, which gets rid of this. And adding 10 to both sides would be the addition property of equality. Right? You added a constant to both sides to get them side by side. So negative 10a is equal to 15. Divide by negative 10. Dividing by both sides of the equation would be the division property of equality. And then a is equal to the simplified version of 15 over negative 10 as a mixed number. So when you see 15 over negative 10, you might have to go off to the side and say, okay, I know they both divide a 5. So 15 divided by 5 is 3. Negative 10 divided by 5 is negative 2. And then 2 goes into 3 one time. And a positive over a negative is a negative. One time with 1 left over. Yeah, and there's your answer. So I'm not going to ask you guys to write these proofs forever, okay? I'm not going to ask you to do it as a proof forever. In fact, I'm just going to ask you to do that in the first 3 sections of this chapter, okay? After 2.3, all I'm going to ask you to do is the left-hand side. So let's look at the next example. I have an eraser. All right, our given is 3b minus 4 parentheses, which means times the quantity. 5b minus 2 is equal to 8. So that's our given. We would first want to break out these 5b minus 2 from the parentheses. So take negative 4 times 5b and you get negative 20b. Take negative 4 times negative 2. Remember, this negative right here needs to distribute to both parts, okay? So both here and there. So you got a negative times a negative, which makes a positive 8. All right? Negative 4 times 5b is negative 20b. Negative 4 times negative 2 is positive 8. The 3b jumps down to the next line. You would say this is a distributive property. The property that gets rid of parentheses through multiplication. Awesome. Second step. Can we simplify the left-hand side? Yes. We don't even have to move anything around because these like terms are side by side. So 3b minus 20b would be negative 17b. All right? I didn't use the commutative property because the like terms were already side by side. So I would jump right to substitution. All right, now it looks exactly as the section 1 problems did, which makes for easy calculations. I need to move the 8 over here with the 8 over there. There's a plus, so I'm doing opposite operations to move it. All right, 8 minus 8 is 0 now. It's negative 17b on the left. And 8 minus 8 That's 0. All right, so this was the subtraction property of equality. Make sure you use SPE and not sub for subtraction. I got sub for substitution already. All right, we're almost there. Divide by negative 17 on both sides, which would be division property of equality. All right, so that creates a 1 in front of the b, which is what we want. And b equals, well, 0 in the numerator just means that there's nothing to begin with. You can divide nothing into as many groups as you want. It's still just going to be 0 every time. It'd be like if I said, hey, I've got $0 and I'm going to divide it amongst 17 people. Everybody gets 0. Okay. Hopefully this is making sense so far. Let's go on to C. Oh. Okay. So just rewriting this so that you see it bigger. Get rid of the parentheses on that first move. So I'm taking a negative 2 times 5c. So that gives me negative 10c. Negative 2 times negative 4 gives me positive 8. All right, the 3c over here just drops down. All right, now I taught you guys last chapter that if it's just a plus here, all right, just a plus in front of the 6 minus 7c, you distribute a positive 1. So positive 1 times 6 is positive 6. Positive 1 times negative 7c is negative 7c. It doesn't change anything inside the parentheses when it comes out of parentheses. So that was the distributive property. All right, next move is let's move the like terms side by side. So I've got a 3c and a negative 10c and a negative 7c. I'm going to move them all side by side. 3c minus 10c minus 7c. So here's all my like terms together. The 8 plus 6 are already side by side. So that's the commutative property in action. All right. At this point, we just want to substitute what we see here with the calculation. So 3 minus 10 is negative 7c. Okay? Negative 7c minus 7c. If they're the same sign, you add them together. And then, yeah, it was negative. It's going to be negative. Negative to start, same sign, add, going to be negative at the end. 8 plus 6 is 14. And that was our sub step. Now, some of you guys might be asking, could we have just said 8 plus 6 is 14 on that line? And the answer is, yeah, you could have done that. You would have to document both commutative property and sub on this step, though. Okay? Okay. It looks like a section 2.1 problem now, so we can just go to our properties of equality to get the constants together. Opposite of plus is minus. That would be the subtraction property of equality, SPE. That's 0. Negative 14c remains. 13 minus 14 would be negative 1. All right, now you divide both sides by negative 14. Negative 14 divided by negative 14 is 1. And I should note my property before I forget. That was division property of equality. Here's something where students oftentimes will mess up what you're supposed to do with negative 1 over negative 14. All I'm asking you guys to do is write the simplified version of the fraction. So you'd ask yourself, do I simplify 1 over 14 at all? And the answer is, the negative over negative creates a positive fraction, but you can't do anything with 1 over 14. 1 over 14 is simplified. That's our answer. It's not equal to 14. That'd be like saying, if I have $1 and I divided it amongst 14 people, then everybody gets $14. That doesn't make any sense at all. Everybody gets 1/14 of $1. So our answer is 1/14. All right, I'm going to stop this video and then put another one on for the last 3 examples. See you in a bit.